Hi, I'm Will Searle, Director of Solutions Engineering at Odigos, and the purpose of this video is to compare OBI to Odigos in terms of the quality of the traces, the depth of the traces, and the context behind it. So what I have here on the right-hand side would be a transaction on an application that I've instrumented with Odigos. And if I open up the process here, you can even see that there's tags for Odigos version, Odigos workload kind, and then even our telemetry distro name, which is Node.js Enterprise. And then on the left-hand side, if I open up the front-end span, we dive into process, you can see that this is instrumented with OBI. So it has the OTel scope name, and then it even has the distro name, which is OpenTelemetry eBPF Instrumentation, otherwise known as OBI. So this is the same exact transaction that I ran on the same exact application. At one point it was instrumented with OBI, which is this trace, and then I ran it again when I instrumented it with Odigos, which is the trace you see on the right. So first and foremost, if you just look at like the depth of the trace, right? Odigos is capturing 66 spans at a depth of 12, and the total duration was 12.8 seconds. OBI had a total duration of 16.7 seconds, so it actually took longer to complete, and then had 9 surfaces at depth of 12, and total spans were 56. So if we open up the first span here, the front-end span, and I go into tags, one of the big differences that you'll see between Odigos and OBI is just in the context that we can provide around these traces. So on the left-hand side, these are all of the attributes that OBI collects on that front-end span. So you're just getting like very basic surface-level attributes like HTTP request methods, the size of the response body, the status code, the route. But with Odigos, you can actually get code-level attributes. So you can see like the code column number, you could see a stack trace, you could see the function name, the line number. Then we can also get the request payload. So you'll see here in JSON the entire HTTP request payload that was sent. We have custom HTTP headers that we've added that we can see within the traces. We also have the response payload, as well as all of your standard attributes, just like you would with OBI. So HTTP route, HTTP target, status text, transport, peer port. So all of this is visible within Odigos. But within the attributes, I have so much more context that's going to help me solve problems on that front-end service if I do have latency or issues or slowdowns. Next, we can see that the front end also captures middleware. So Odigos is able to capture middleware within my Node.js service. Within OBI, it does not capture middleware. So the big difference between Odigos and OBI is that Odigos is instrumenting at the library level. So it's seeing everything inside of the application versus OBI, which is really just operating at the syscall level. So it sees everything down inside the kernel, but it doesn't actually see what's going on inside the application. We can also see custom instrumentation. So process request is a custom Java method that we can define, and without code changes or restarts, Odigos can capture spans for process request, as well as all the arguments, and then the return value for those arguments as well. There's no way to do that with an OBI for any programming language. So if you have custom code that you've written, that's going to be a large blind spot for you today within your tracing story. We also have MySQL internals. So Odigos supports instrumenting databases out of the box. So MySQL runs on Kubernetes, but you can see everything here from the locks, the unlocks, any other internal spans inside of the database. The OBI span stops here with the call from the product service to MySQL. And in speaking of databases, if we open up the product service select statement here, so on the OBI side, these are the attributes that we can see on this database operation. Note that there is no database query. Odigos is able to dynamically capture database queries, meaning you can turn this on and off as you wish. But if we open this back up, again, I get my code attributes, my stack traces, but we'll also see the database statement here. So obviously a very useful tool when you're debugging database problems. You can figure out which query may have caused a problem or an issue. But you have your database statement, you've got your database user, the database itself. So a lot more information here than what OBI is providing. Towards the bottom, we have the inventory service and the notification service. So these are Kafka producers and consumers respectively. The inventory service is posting or publishing a message to the orders events topic. If I open up this span, one of the unique things that Odigos can do is we can actually enable messages within Kafka. So this is the message that the producer is sending to the consumer, and we can see both the producer and on the receiver side what the message is that is being translated or sent to the broker and then to the consumer. I also get context propagation, so I can see the inventory service stitches across the broker and into the notification service, whereas on the OBI side, if we look at the inventory service, the trace stops at Kafka. So the inventory service has this publish orders events, does not include the message because there's no way to add that within OBI, and also I don't see my notification service. So there's no context propagation or trace context propagation flowing through the broker with OBI. Odigos can do it, and Odigos can even do it if you're using third parties broker services like Confluent. And lastly, I have the order service span here, which is taking 10 seconds to complete. So in this one database operation, if I open up the tags, I get the error type. So I can actually see the database query, I can see the error, and then the description, which is lock wait timeout exceeded, try restarting the transaction. So it's actually telling me that I have a database locking problem. It occurred on this one span with this particular database query. And then if we look at the same thing on OBI, it's actually able to recognize that there is an error on that update inventory span, but there's no context. Right? I don't get the database query. I don't get the error message. I'm sort of blind to understanding what happened on that operation. All I know is that there is some error on it. But those are just some of the high-level differences. There's other differences within Odigos where we have everything from a nice UI, built-in OTTL, and transformations that you can use from that UI. We deploy and manage and maintain an OpenTelemetry pipeline for you, so we actually deploy collectors and update that collector config. Whereas with OBI, you're still going to rely on creating your own OpenTelemetry collectors and maintaining that going forward. But all of this, I'm happy to hop on a call to show anyone live. But thanks for joining and watching the video, and have a good day.